So hello everyone, in this video we'll do this question which can come in your long question part, and this question is having two parts. First part we'll do in this video and the next part we'll do in another video. Okay, so the question is, when two resistors of resistances R1 and R2. We are having two resistors R1 and R2. These two resistors are connected in parallel. When these two resistors are connected in parallel, the net resistance is RP is resistance in parallel is 3 ohm, and when they are connected in series, series में battery would be connected like this. Along the series parallel में battery would be connected separately. Clear? So when they are connected in series, its value is RS is equal to 16 ohm. Find R1 and R2. The resistance in parallel and resistance in series is given, and what we need to find is we need to find R1 and R2. So firstly we will make equation resistance in parallel. What is the formula for RP? 1 upon RP equals 1 upon R1 plus 1 upon R2. Now substitute the values. 1 upon 3 is equal to 1 upon R1 plus 1 upon R2. Now take the LCM. LCM of R1 and R2 would be R1 into R2. Just like the LCM of 1 upon 3 plus 1 upon 8 is 1 upon 3 multi 8, which is 24. In the same way, these two resistances are different, so the LCM would be the multiplication of both. And now cross multiply, it would be R2 plus R1. Now do the cross multiply first. R1 R2 into 1 would be R1 into R2, and 3 times R2 plus R1. That means our equation will become R1 R2 is equal to 3R2 plus 3R1. Name it as equation number 1. Now use this value. Resistance in series is equal to R1 plus R2. In place of RS, you will write 16 is equal to R1 plus R2. Now find the value of R2 from here. It would be 16 minus R1, and put this value of R2 in equation number 1. You will get R1 into 16 minus R1 is equal to 3 times 16 minus R1 plus 3 times R1. Solve it. It would be 16 R1 minus R1 square is equal to 16 3 is 48 minus 3 R1 plus 3 R1. Plus 3 R1 minus 3 R1 cancelled. Now we'll take these terms on the other side to make square's term positive. It would be R1 square minus 16 R1 plus 48. Here we'll get is equal to 0, and is equal to 0 we can write it on any side. Now you will make the factors. 48, what would be the factors of 48? 12 fours are 48. Minus 12 R1 minus 4 R1, and 12 fours are again 48, and 12 plus 4 is 16 also. Now take common. R1 minus 12 minus 4 R1 minus 12 is equal to 0. This is the basic mathematics, that's why I am not explaining it over here. Now it would be R1 minus 4, R1 minus 12 is equal to 0. Now either R1 minus 4 is equal to 0 or R1 minus 12 is equal to 0. And from here you will get R1 to be 4 or R1 to be 12. When you will take R1 to be 4 and when you will put it in equation number 2, you will get R2 to be 16 minus 4, which is 12 ohm. And when you will take R1 to be 12 in equation number 2, you will get R2 to be 16 minus 12, which is 4 ohm. That means our two resistances would be 4 ohm and 12 ohm. So this was the first part of this numerical, and the second part we'll do in the next video. And if you want further more details, you can join our paid batch, and in which we'll give you the whole science class 10th overview in just 45 days. It would be a crash course, it would be paid, and we'll give you one-on-one personal mentoring. So if you're interested, comment down below, we'll reach out to you.